So welcome to this video. In this video, we'll be dealing with some miscellaneous questions that involve differentiability. In our previous videos, we came up with the understanding that for a function to be differentiable, it needs to, one, be continuous. And once it is continuous, it also, the limit of the derivative has to exist. So the limit of the derivative must exist. So let us dive into this question. So determine the values of P and Q if f is differentiable at x equals to 1. So what we do understand is that a function is differentiable if the limit exists. So we'll take the limit as x tends to 1 from the left. If we go to 1 from the left, we bump into this function, but therefore we need the derivative of this function. So it will be the derivative of that function must equal to the limit of, as you approach 1 from the right, of the derivative of that function. So in essence, we have ourselves a situation where x minus 1, where x approaching 1 from the left, the derivative of that is of course 2x plus 3. And therefore, once we have the 2x plus 3, we can then take the limit of 2x plus 3 there by substituting 1. So this becomes 2 times 1 plus 3. So therefore, we get 5. So the left-hand side of our situation is 5. And therefore, if we're approaching f of x from the right, we'll end up with the limit as x tends to 1 from the right. But now of the derivative of this function, which is just q. So which means that is equals to q. And therefore, by working this out, we get that q is equals to 5. So we have now essentially solved for what q is. Q is equals to 5. Let us look at the second part where we now need to determine the value for P. But once we find the value for Q, we also know that the function is continuous. So for a function to be continuous, 3 conditions must be true. So we know that the limit as x tends to 1 from the left of f of x must equal to the limit of x as it tends to 1 from the right, and also must equal to the limit of f of 1. So we know the statement to be true. So let us see what happens. So if we're approaching our function f from the left, then we bump right into this function. So therefore, we get the limit as we go from the left. We jump right into this function that we have here, which is x squared plus 3x plus p. If we're jumping straight from if we're approaching this from the left, from the right, we then bump into this equation now of the limit of as x tends to 1 from the right of now qx plus 2. So from here, once we've done this, we then obviously take our limits and substitute them accordingly. So this becomes 1 squared plus 3 plus p, now equaling to q. We substitute 1 there plus 2. But remember that in our previous working out, when we did differentiability, we were able to work out what the value of q is. So we will sub in q as 5. So now on this side, I've got 5 plus 2. On this side, I've got 3 plus 1, which gives me 4 plus p. And once I've got 4 plus p, I can take everything to the other side, and I can easily work out that p is going to equal to 7 minus 4, which is therefore equals to 3. So now the values of p and q that make this differentiable is where p is equals to 3 and q is equals to 5. I hope this example has made sense for you, and therefore I shall see you in the next video.